Hi, this is GP here. Let's get started with the session. And today we are looking at the 14th session of the DILR Jugaad series, where we are looking at different sets of data sets of CAT from 17 to 24, and look at which are the sets in which we can apply Jugaad solution. And today is, as I said, the 14th session. And so let's get started with it. But before we start, just one quick word for those of you who have just started preparing, or those of you who have are repeaters and want to just go through the study material once again. So if you have started preparing just now, you think your preparation is not up to the mark and you're looking for support, or you are the repeater and you would want to have a short program which will help you go through all the basics and help you prepare well, this is the program for you. Sprint, CAT 25 Sprint, and the best part is it's a very low price product, 15,000 only, and covers everything. Classes are, I think, 5 to 6 days a week. So you'll have a full engagement. It includes a test series also. And if you think it's only verbal, that's an issue for you, on the quant or on the DIL, and you want to focus on that area itself, I think you can take this as a sectional paper also, with preparation also, which means you need not take the full program, but you could look at only the quant or only the English or only the DILR also. Okay. So if you think you need some support, there's a program you need to look at. Okay. Let's get down to the session that we have. And here we are looking at the second section of CAT, which is the 40-minute section of DILR, data interpretation, logical reasoning, in which we typically get 40 minutes to do for about 20 questions. And these 22 questions last year, and this year also we expect it to be 22 questions only. And this is likely to be the same. And this is typically 4 to 5 sets of data. Last year in CAT 24 it was 5 sets, and I would assume the same will continue. Okay. Now, before we start the session, one thing which I keep repeating every time, let me repeat the same: a 50% score, okay, 50% marks, not percentile. 50% marks is a very good score in CAT. And just to prove my point, you look at the last 5 years papers of CAT from CAT 20 to 24. The number of questions in CAT 20 to 24 are given out here, and so are the marks, total math marks. So what is 50%? 50% in each of these years would be 36, 30, 30, 30, and 33. Now, please look at it. Where would you be if you had only 30%, only 50% marks? At 50% marks in CAT 2020, you would have been above 99 percentile. Okay. Similarly, if you look at CAT 21 at 30 marks or 50% marks out of 60, you would have been somewhere around 97 plus percentile. 97, 97.5 is what you would have possibly scored. Next year in CAT 22 at 30 marks, which is 50%, you would again be above 99 percentile. And in fact, in CAT 23 with 30 marks, you would be close to 99.5 percentile, because 99.5 percentile was 31 marks. And last year in CAT 24 at 33 marks, you would be somewhere again between 97, around 97.5 percentile. So what I need you to remember is that 50% marks will typically get you somewhere from 97.5 to 99.5 percentile. And which is why the Jugaad method that we do are extremely useful, because what they will do is they will help you attempt at least one extra set in the paper, and which will help you zoom to a 99.9 odd percentile. If you are doing 3 sets right now, you'll be able to do 4. If you're doing 2, you'll be able to do 3. So you'll definitely be able to attempt one extra set, because the time you'll save will allow you to do one extra set. Okay. So let's look at the approach that we follow. We follow the Jugaad approach, and very quickly, Jugaad is a problem-solving approach which says, please focus on all available information. And when we say all available information, remember, information is available in the question, in the choices, in the basic data also. And most people ignore the question and the choices, which is what we also look at. And then at the end of the day, there's some common sense thing which you need to apply in a logical way, and not be too bothered about the negatives. Okay. Secondly, the focus of Jugaad is on solving questions. Our focus is solve the question. We are not too bothered about filling the table. Unfortunately, many students think that their job is to fill up the table. Sawal dekhte nahi hai, table bharte rehte hain, and they do all kind of wrong things. So remember, yes, I have to fill the table to the extent required by the question. Nothing beyond that. Okay. So please remember, my job is to answer the question and not fill up the table. I'll fill up the table to the extent required by the questions, and which is why I have to look at the questions before I start solving the filling up the table. Okay, so let's look at the basic methodology that we use. It is again called DILR. D is for decipher. Decipher means the data which is given to you, the paragraph, the graph, the chart which is given to you, please understand it. Only if you understand it, you will know what exactly are you supposed to do. Okay. So after you decipher the data, next step is to identify. Identify the information in the questions. Typically, this is the aspect which students ignore the most. They read the data, start making the table and start solving it. Look at the questions. Questions many times will give you some extra information. Questions many times will help you also understand what is should you be focusing on. If you have to make a table, if you have to tabulate the data, where should your focus be? All that information comes from the question. And as I said, ये चीज बहुत स्टूडेंट्स छोड़ देते हैं, इसलिए तकलीफ होती है. Third stage is called the layout, which means tabulate the data. Layout is nothing but make the table or tabulate the data. So once you tabulate the data, okay, but you tabulate the data keeping the question in mind. Okay, and then finally you look at solving the questions. So resolve is nothing but solve. Okay. So then you look at solving the question. Okay. Yeah. So tabulate, keeping the question in mind, and then you solve, and make sure this is a back and forth process. You make a part of the table, go to the question, eliminate choices, get the answer, pick up more information, fill up the table. So between the table and solving and questions, you have to keep going back and forth so that you are able to get the answers faster. Okay. Now, I hope you have downloaded the exercise that we are doing. If you not, please pause the video now and download the exercise, solve it yourself, and then we will look at. Then only then you should look at the solve going to the video that this particular video that we are doing. Okay. And where do you get it? You get it in the OpenCAT. In the OpenCAT, if you scan this QR code which is given out here, if you scan the QR code, you will be able to go to OpenCAT. There's a tab of GP ka Jugaad. Please go there. Out there, you can already see 12, 13. This is only showing 12, but there are 13 sessions. For each session, there's a PDF and a video. Your job is to first download the PDF, solve it, and then then watch the video. Okay. For today's session, also you'll find only the PDF, not the video. Obviously, the video is being created now. Okay. So go to the PDF, try solving it yourself. After that, look at the video to understand if you have done it right or it was a better way of doing the set. Okay. And in addition to this, OpenCAT has lots of free study material, helps you understand your preparation. And if you're a self-prep student preparing on your own, this is a great place because not only does it have old solutions, or it has got some full-length mocks also. It has got some study material and concept building session and Jugaad solutions as well. Okay. Chalo, let's look at the set from CAT 2017. This came in slot 1 and my slot only. This was the paper I took. Okay, so let's see what does the set say. Okay, 4 cards needs to travel from A to B, Akala to Bakala. Okay, A to B. 2 routes are available. One via M, other via N. The roads from A to M and N to B are both short and narrow. In each case, one card takes 6 minutes to cover the distance, and each additional card increases the travel time per car by 3 minutes because of congestion. For example, if only 2 cars drive from A to M, each car will take 9 minutes. That means 6 minutes normal. Because of congestion, extra 3 minutes for each of the cars. So each car becomes 9 minutes. On the road from A to N, one car takes 20 minutes and each additional car increases the travel time per car by 1 minute. On the road from M to B, one car takes 20 minutes and each additional car increases the travel time by 0.9 minutes. Police department orders that each car to take a particular route in a manner that it is not possible for any car to reduce the travel time but not following the order, while the other cars are following the order. Okay. Now so broadly we know that routes available. The routes are A and B and A and B. Okay. If I look at here, effectively it is telling us that there are 2 routes possible. From A to B, you can go via M or you can go via N. These are the 2 routes available. And there are some times given out here. Okay. And there are a total of 4 cars. and we need to obviously we'll need to decide which car will take what route based on the condition, minimizing time. Minimize the time for everyone. Okay. Question number 1, theta. Question number 3, theta. Okay, so question 1 and 3 are theta, while question number 2 and 4 are giving us time slot. Let's read the questions. Okay. They are giving us not time slot, they are giving us choices. Okay. How many cars would be asked to take route A and B by the police department? Okay. Question number 3 and 4 also have some additional information. Question 2, if all the cars follow the police order, what is the difference in travel time in minute between a car which takes route A and B and the route A and B? Okay. Chalo. We'll come to this. We'll look at understanding this data fully and making the table, but this seems to be doable. And the best thing is that this has got only 4 cars. In the worst case, what do I need to do? It could be 4, 0, 3, 1. Number of cases that I need to make 2, 2, 1, 0. 1, 1, 3, and 0, 4. Obviously, 0, 4 will not be the case. Okay. And it is going to be in the worst case. I need to look at making these cases and getting the answer. So there's a set which appears to be doable. Okay. Similarly, let's look at question number 2. Okay, question number 2, what is the difference between A and B and A and B? Now look at this question. This is telling you there's at least one car which will take the A and B route and at least one car which will take the A and B route. Okay. Now, that means, which is why I eliminated the case of 0, 4 and 4, 0. These are the 3 cases which are possible. So in the worst case, I will end up making these situations, checking the situation, getting the answer. But once I put the data, I may not need to do that also. Let's look at question number 3 and 4. A new one-way road is built from M to N. Okay, so a new road is created like this, M to N. Now each car has 3 possible routes to travel from A to B, A and B, A and B, and AM and B. On the road from M to N, one car takes 7 minutes. Each additional car increases the travel time. Okay, some information is given. We can look at that. Now question number 3. How many cars would the police department take on A and B route so that it is not possible? Again, to minimize time. Okay. Question 4. If the car follows, what is the minimum travel time in minutes from A to B? Great. So doable set. In the worst case, I may need to make cases, but it is quite possible I may not need to do any of such thing. So even if I have to make the cases, these are the only 2 cases which are possible. In the only 3 cases which are possible. Okay. So let's now look at the information again and start solving the data set. Okay. Because so far I have not put the numbers or the time correctly. Okay. 4 cars need to travel from A to B. Okay. 1 via M, 1 route via N. Okay. So we have A to B. 1 route goes via M, 1 route goes via N. Let me make it a little bigger. Okay. Okay. So what does it say next? The roads from A to M and N to B. A to M and N to B. Okay. Are both short and narrow. In each case, one car takes 6 minutes to cover the distance, and each additional car increases the travel time per car by 3 minutes. Okay. So in both of them, the travel the distance, each car will take 6 minutes. And each additional car will increase the time by 3 minutes. Remember, each additional, so there are 2 cars, the time for AM becomes 6 plus 3, 9. Each car will take now 9 minutes. Similarly for NB, it is 6 minutes and each additional car means 3 minutes extra. Okay. Because of congestion. And if you remember the example, for example, if only 2 cars drive from A to M, each car will take 9 minutes. 6 minutes is the normal time, 3 minutes extra due to congestion. On the road from A to N, 1 car takes 20 minutes. So A to N, 1 car will take 20 minutes. Okay. And each additional car will increase the travel time per car by 1 minute. So additional car means plus 1 minute per car. Per 1 minute, 1 minute for every additional car. Okay. On the road from M to B, one car takes 20 minutes and each additional car increases the travel time by 0.9 minutes. Okay. So M to B, it is 20 minutes and plus 0.9 minutes. Okay. Police department orders each car to take a particular route in a manner that it is not possible for any car to reduce the travel time by not following the order, while other cars are following the order. Okay. Question 1. How many cars would be asked to take the route A and B by the police department? Now, pehli cheez yaar, you want each car to have minimum time, na? And what is the time on each side? This 6 minutes. If I look at these this is 6 minutes. This is 6 minutes. This is 20 minutes. This is 20 minutes. The extra time is 3 minutes. Extra time is 3 minutes per car, per additional car. Extra time is 1 minute per extra additional car. Extra time is 0.9 minutes per extra car. Is there any significant difference? नहीं यार, कुछ भी फर्क नहीं है. इसमें तो without thinking you can say A and B should be 2 cars. A and B should be 2 cars. After all, when the time in both directions is almost the same and the incremental time is also the same, मैं बेकार में calculate क्यों करूंगा? I will straight away write this is 2. So as far as I am concerned, it's going to be 2 cars only. So I don't need to worry about anything else. And if you are now going to make cases, you are going to be only wasting your time. Because logically, socho yaar, from both the routes, this way and this way, 20 plus 6, 26. 20 plus 6, 26. Isn't it? If there are 2 cars on this side, 26 plus 3, 29 plus 0.9, 29.9. If there are 2 cars, 29.9. And if there are 2 cars here, 21 plus 9, 30. I got both the answers. Okay. So this was a straightforward question. If you just think logically, when both sides A and B, the time is almost the same. Will I not say equal number of cars? Let car 1 go this side, car 2 will go this side on through A and B. Car 3 will come to A and B again, and car 4 will come to A and B. So equal number of cars on both sides because the times are almost the same. If you are going to make cases and say, let me check for 1, 3, 3, 1, 2, 2, you are wasting your time. Chup chap 2, 2 karo. And secondly, what is the difference in the time? We have already calculated. If there are 2 cars, just to repeat, if there are 2 cars going from going via A and B, if there are 2 cars going via A and B, there will be 6 plus 3, 9 minutes for AM and 20.9 plus for A and B, for MB. So how much does it become? Why 20.9? Because 20 minutes, and because there are 2 cars, it will be additional 0.9 minutes per car. So 29.9 minutes. Similarly, if there are 2 cars going via A and B, it will be 21 for A and because there are 2 cars, and 6 plus 3, 9 minutes for A and B. So this becomes total of 30 minutes. Okay. Or the differences as we marked 0.1 minutes. Okay. So don't make cases chup chap karo. And logically, so this would have been the problem. There are a larger number of cars, but even then, I would say even if there were 10 cars, I would say blindly, 5 idhar se, 5 idhar se. सोचना ही नहीं है because the timings are almost the same. That is my basic thesis out here. So let's look at the remaining 2 questions where there is some additional information also. So let's draw the figure again. Okay. A and B, A and B. And what was the data given here? 6 minutes plus 3 minutes. AM is 6 minutes per car. And additional 3 minutes to cover the distance if there's an additional car. So every additional car, and similarly, MB was 20 minutes and additional time of 0.9 minutes per car. Similarly, if I look at AN, what was the data? 21 and 6.3. Okay. It is plus 1 minute. Normal time is 20 minutes. If there's 2 cars, every additional car will increase the time of travel of for AN will by 1 minute. And similarly, this NB was in any case 3 minutes additional per car. And the normal time is 6 minutes. Okay. Now, what does this information tell us? A new one-way road was built from M to N. Now the possible C routes from A to B are A and B, and AM and B. Okay. On the road from M to N, each one car takes 10 minutes, and each additional car increases the travel time by 1 minute. Each additional car increases the travel time per car by 1 minute. So M to N, if we have, what does it mean? 7 minutes. And each additional car increases the travel time per car by 1 minute. Okay. Now, assume that any car taking the AM and B route travels the AM portion at the same time as other cars taking A and B route, and NB portion at the same time as cars taking A and B route. Okay. Now, question number 3. How many cars would the police department order to take AM and B so that it is not possible for any car to reduce the travel time by not following the orders while other cars follow the order? Okay, great. Now, what are the routes available? We have A, M, B. Then we have A and B. And then we have AM and B. 3 routes available. Okay. Now, if these are the 3 routes which are available to us, okay, if these are 3 routes available to us, then 4 cars. What is the time? If you look at, if there's only one car taking A and B route, how much time will it take? A and B is 26 minutes. And what is the time for A and B? If there's only one car, again 26 minutes. And AM and B? A, M, and B. What? It will be 6 plus 7, 13. 13 plus 3, 16. It is 16 minutes. 7, 6, 15, 15 and 3, 8, 18. Sorry. 6 plus 7, 13. Yeah, 16 to ahead. Get 16 minutes. Now, what does that tell you? AM and B will be the preferred route. AM and B has to be my preferred route. I should route the maximum number of cars from here. So, how many cars are there? There are 4 cars. What should be the routing? 2 cars from here, 1 from A and B, and 1 from A and B. The number of cars from A and B have to be the same. If that is the case, again, all I'm saying is, given that AM and B is the preferred route, the number of cars from this side and AM and B and A and B has to be the same. So AM and B the maximum. So if I look at A, M, B, A, M, N, B, A, N, B. So can this be 400 or 211? These are the only 2 possibilities. Can I have 3 here? If I have 3 here, that means either this is 01 or this is 10. Doesn't make sense. Because the timing for A and B are so close that it does not make sense to differentiate between them. Both have to be equal. So I would straight away say, यार ये तो नहीं हो सकता. ये 040 भी नहीं हो सकता. क्यों? Because if there are 4 cars taking this route, what does it mean? 4 cars taking this route. That means the maximum this time and this time will become huge. Not possible. So straight away you should start by saying, यार इसमें जो है, how many cars will take the AM and B route? 2 cars will take AM and B route. Okay, and then you can look at the rest of the stuff also. Let's look at the rest of the stuff. Okay, how much time will be taken on each route? Okay. 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 You could either do it directly or you could look at cases. Okay, so if I look at A and B, okay, so let me put AM and B, sorry, and A and B. Okay. Now, what have we decided? We have decided 2 cars going through MN, 2 cars taking this AM and B route, 1 car taking A and B, and 1 car taking A and B. This is absolutely logical. Again, I'm repeating, the time for A and B is almost the same. While AM and B is significantly lower. AM and B, the time for 1 car, if it is only 1 car which is taking AM and B route, what is it? 6 plus 7, 13 plus 3, 16 minutes. If there's only 1 car taking A and B route, it is going to be 26 minutes. If it is only 1 car which is taking the A and B route, it is going to be 26 minutes. What is the difference between them? Look at this, 10-minute difference. So that means there should be at least 2 cars here. At least 2 cars should be visible because every time I add a car here in AM and B, the time will go up by 3 plus 3, 6 plus 1, 7. So if one more car is added, if it is one car only, it is 16 minutes. If one more car, it is 7 minutes here. Okay. If one more car is added to AM and B, it becomes extra 3 minutes here in AM, extra 1 minute in MB, extra 3 minutes in NB. So 3 plus 1 plus 3, 7 minutes. Okay? So even then it will become 23 only. So you can safely be clear कि यार दो कार तो पक्का जाएंगी इधर से. And as I said, given that there is no time difference between A and B and or negligible time difference between A and B and A and B and A and B, these two have to be equal. So what are the possibilities? 400 or 211. I will obviously go with 211. 400 not possible because then the time will increase significantly. Because the moment you do this 4, what does this mean? If there are 4 cars going in the AM and B route, if there are 4 cars in the AM and B, what will this mean? 3 3s are 9 plus 6, 15. 15 minutes for AM. If there are 4 cars going through MN, it will be 7 plus 3, 10 minutes for MN. And if there are 4 cars going through NB, again it will be 15 minutes. It will be 40 minutes each car. Yeah, 26 minute wala rasta nahi lunga kya main phir. Okay. So chalo. So this is very clear to me that it can only be this one. Okay. So let's see. Now what if now what does this mean? Effectively, this means A, M, B, A, and B. How many cars will be here? Okay, let me write it on the same thing and I'll write it in a different colored pen. Yeah. So A, M, and B, there have to be 2 cars. A, M, B has to be 1 car. A, M, B has to be 1 car. That means across A, M, there should be 3 cars. Because 1 car will go to A, M, B. 3 will start from A, M. 2 will get diverted towards M, and 1 will continue to M, B. Similarly, what about A and B? 1 car will start from here. And along with M, N, there 2 cars are coming, there will be 3 cars here. Now, this is also again logical. Given that the time for this section and this section is same, I should have equal number of cars in both these sections. Okay, which is what we can see again. So this is going to be the scenario. Okay? So how much time for each of these segments? Okay. So A and B, it is only 1 car is going 26. But what is happening? AM, there are going to be 3 cars. If there are 3 cars going through AM, that means extra time will be 6 minutes plus 6 minutes. So A and B will take me 32 minutes because MB there is only 1 car. Similarly, A and B, how much extra time? AN is only 1 car, so 20 minutes. But NB, there are 3 cars now, so additional 6 minutes plus 6, 32. And what about AM and B? As far as AM is concerned, 2 extra cars. That means additional 6 minutes. As far as MN, this is extra time for AM. What about MN? How many cars? 1 extra car, so plus 1 minute. And NB, again 2 extra cars, so another 6 minutes. MN, NB. 16 and 2 extra cars, so 6 minutes out here. Okay. So extra 6 minutes here. 6, 6, 12. 7, 6, 13, 13. Oh, I made a mistake. Okay, this is fine. This is not 16. I thought I corrected this. 7, 6, 13, 13, and 6, 19. This is 19. Okay, after all, this is 6 minutes, 7 minutes, and 6 minutes. 3 minutes is the extra incremental time. Okay, so this is 19. So 6 minutes here. 2 cars in MN, so 1 extra minute, and 3 cars in NB, so 3 to 2, 6 extra minutes. So how much does it become? 6 plus 6, 12, and 1, 13, 32 minutes. Okay. So this is the time going to be. Now, and that means the answer for question number 4 should be 32. If all cars follow the police order, minimum travel time is what we needed to find, and that is what we got. So if you look at, while I've taken it a lot of time to explain, ultimately what does it do? But if you read the data, you can clearly say, without doing any calculation, this question should be straight away 2. Because as I said, equal number of cars should go on each side. And hence you can straight away get this. And based on 2, 2, you can get the answer. Similarly, when you look at here, Again, the issue is how many this way, how many A and B, and how many this way. So A and B has to be 1, this has to be 1, this has to be 2. Why? Because this particular route has the minimum possible time and the gap is huge, 26, 19 and 26. That means there's a gap of 7 minutes between these two. So I can definitely accommodate one more car. And the number of cars which are going through A and B have to be equal. Okay? So there's only one case which was possible, and that is what you should be marking the answer accordingly. Okay. Okay. So that completes the session. I hope it helped you. And as I've mentioned earlier also, in case you're looking to prepare only for DILR, this is a program which is being run by Gautam Bawa, Gautam Puri and Ravi Teja. You could look at joining it. In case you have any issues, any problem with respect to your preparation, you can always connect with me at 9811155160 or alternately on my email ID at gp@careerlauncher.com. Okay. Okay, so that's it from my side. All the best. Hope to see you again next week.